in famine areas. And in these areas, there's obviously not a lot of food. And the people living in these areas don't have the nutrients, the daily nutrients that they need, that all humans need to live.
And currently food and water are distributed, but they are two separate items or two separate products, which makes for two things a whole, along with either going through one line to get these products or going through two separate lines.
So the solution that we created was an edible container that contains 16 ounces of water and a daily vitamin supplement. The main material that it is made out of is a wheat-based product that is currently used in the making of edible bowls and silverware. The inside of the container is lined with a product called WikiCells that was created by a Harvard professor that is also edible, and it keeps the water from permeating the material. Also inside of the container is a smaller compartment that you break off that holds vitamin powder that you break off, and it goes into the water and you shake it up and then drink it. So both the wheat material and the WikiCell material are edible, and they have nutritional values such as calcium. Also, even if you do not eat the container, it is biodegradable, so it is a no-waste product.
So basically why this product is so great is, one, it's really cost effective, and two, the shape of it is really unique. So usually like with a water bottle, like there's empty space when you ship it, like between, because it's curved. So with these, it still holds everything, and when you pack them all together, they're still going to be very compact, and we're not wasting space in that way either. And what makes it so cost effective is that the main product that we're using here is a wheat-based material. Wheat is grown practically everywhere. It's a very versatile crop, and so that way you can make it wherever you want to distribute the product. But although we realize that the WikiCell, since it is such a new technology, it was created in 2012, I believe, by the professor, and that's basically, it's a charged polymer and food particles product is what it is. And so we realized that that will be costly, so that's why this whole product isn't based off of that. And so since we're just using a liner, that will reduce the cost of that aspect of this product. And here, we're still holding like the 16.9, the typical amount of water that's in a water bottle. And then you'll have your 4 teaspoons of the daily vitamin supplement that goes in that container. So it's really great because you're not holding like 2 things, because we were gonna do like food and water together, but we combined it to do the vitamins because that's more essential and it gives you everything that your body requires. And it's in one product which you really like. Even though it is square, so like people aren't usually used to like holding like a square object to like drink out of, the fact that like you're only gonna be holding it for like as long as it takes you to drink it, we think kind of makes up for that. And that aspect, we did kind of prototype with some like circular ones and everything like that, but we thought that this was the best way to go about it. Also, it just provides, since we combine them together, it provides for like quick and easy food distribution. And there's just, it can even go farther than just famine. You can do it with disaster relief, but that kind of opens up the logistics problem. And then like Red Cross stands, and you can even use it for rations. We also went to test it, and using this, we used ice cream cones from the dining hall. So what we did was we used different liners to try to simulate the WikiCells. We had 3 different ones. We used a balloon, a baggie, and then wax paper. And we let it sit for a period of over 24 hours.
Is there more in your group?
Yeah, Chris is saying it.
Okay.
How is the wheat is, the material is accessible because it's grown everywhere, but how is the product processed into whatever it is, the shape or sheet material?
That we didn't yet get to, but I think they wouldn't be, they have these wheat bowls that is what they originally make, and right now they're being produced, there's a company that is producing them in South Africa, and so I think that could like even help there, because it's not just in the US, so it wouldn't be just that. So like this company can modify their product, their factory to be able to make these two because it would be mostly the same product. They would just be adding another aspect to it.
I think that's a significant issue that you need to address, and not to say that it's insurmountable. It's just something that is something that I think is a glaring issue. That while the material may be present all around the world, or at least a lot of the world, that the ability to make it into a sheet material, and then also the idea of how does the liner material get applied to it? Is it sprayed on, or is it how is it applied? And does it need to be in the box shape in order to be applied? Because then you've got sealing you have to do between all the joints. Or is it more like when I didn't know this until just recently that somebody had a picture on Facebook that's this Asian food box, and what you do is, I didn't realize this, but they're meant to be unfolded and used as a plate. And so, is there a way that it can be processed as a sheet material and it's folded up to be able to create this shape?
Well, I think you can also like bake it in the shape too, because that's how I'm pretty sure the bowls are made. We couldn't figure that out exactly, but it's like molding something to it, like a container. So like you would put the sheet, it'd be in a sheet form, and then you have like a rectangle that the sheet goes over.
Right, but if it's in this shape, getting the material in there, getting it fully covered and in even mount may be difficult to do. Right? So what I'm saying is that the sheet you can then hold it up. So I think that's smart also that you did as a box, but I think that there's precedents like say the milk carton, where there is the ability to manipulate the top of it in some ways, but it's easier to drink out of. The square flat surface might not really be the best to drink out, so you might really consider, is there a way to kind of crease this and create something that's better to kind of funnel the liquid down? Because what happens is if it's a square flat surface, it's going to be a sheet of liquid that's going to come out at you instead of pointing it towards one spot, which is what you want for a coating. So the ability to manipulate that to respond to the ergonomics would be beneficial. I think you've also identified, you've identified a target use, but I don't think that you've done, at least you didn't present that there's a lot of research into really, like what is the demand for this, and how would this mean, like how many people really need this, who is it for? And so while there's empathy of defining who that person is that you're targeting, I don't know that at least we haven't seen evidence of you really getting into a strong understanding of who that user is and how it really informs the project in a meaningful way. I think it's an interesting product. I think that you've aligned yourself with existing technologies and things like that to where you kind of brought a lot of different things together, like the Harvard professional material and the wheat material and the accessibility. I think there's some good research that went into the sort of justification of the project, but I'm looking for a little bit more as to how the user really informs this project in a more meaningful way.
I would say that I was missing the piece of and we've talked about this in class outside the presentation. The presentation didn't really take me through how you guys got from first thinking about this to your targeted user. Just kind of start. This is who we're targeting without a lot of